the terminology we use. It's kind of neat. Give me a minute here. In fact, has anybody ever told you, like, you must have heard the word cross product before. I don't know if you've teacher. So this, if I said 4x times 7 and negative 1 times 3x, those are cross products. They're going across. They're not direct products. So sometimes you actually see a dot product called a direct product. They're not direct. They cross over to the other component, right? So I don't know if anybody ever heard cross product before that. And when somebody multiplies it and get this, I tell them, oh, you lost your cross products. So I tried to use that terminology early. All right. What does it got to do with shit? I don't know. So watch this. A1 times B1. All right. Let me see. All right, this is exciting. Plus A1, B2. Right? And so forth. Plus A1, B3. And you can imagine, and then I'm going to get plus A2, B1, plus A2, B2, plus A2, B3. Don't even write this down, please, dear God. A3, B1, plus A3, B2, plus A3, B3. This, and this are what?
The dot.
And dot product. Direct product. I love it. That's why it kind of makes sense. I showed you earlier, when you combine the dot product and the cross product, you get this total product kind of thing. This by itself doesn't necessarily mean shit, but all of these parts are here. They're all the cross products from that multiplication. You guys with me? All those pieces that are here are the cross products from that. I know there's no minuses and shit, but I still like that idea because that's what we call those. Those are cross products. Okay, maybe. So again, this does not have anything to do with anything we just derived. It's a side note. This is one reason why we call it the cross product, because it picks up all the cross stuff, all the cross products, not the direct products. Those are dot products. I don't know if that did any good for anybody, but all right. Just explain why we call it what we do. Okay, so we still have to talk about what's true about this vector result. Where does it live? What does it look like, right? I know it's this. We can calculate it just by multiplying and subtracting, right? No big deal. In fact, let's do that first, and then we'll talk about the geometry of it, and then we'll probably head out. And again, just the next Thursday, there'll be a lot less talking on my part. But I want to get this all out there so we can work it on, not Thursday, Wednesday. Oh. Okay. So if I gave you these. Calculate the cross product. Not the length of it. I know. Well, at least he hung out in time just to watch what I was asking.
Yeah.
And then he said, no, I don't think so. So, I mean, you guys realize it's just a matter of, multiplying the correct things in the correct order. That's all it is, really. It's not nothing too intense. So you can call this A1, A2, A3, B1, B2, B3. So this officially is A cross B. Something interesting is A cross B does not equal B cross A. The cross product is not commutative. Shit. Too bad. So sad. It's pretty close. It's almost commutative. It's the same length, just different direction. So we're going to do A cross B. Maybe you guys could see why, because of the minus, it would just all become the opposite sign, wouldn't it? So it's just pointing the complete opposite direction, 180 degree complete opposite direction. So it'll be A2B3 minus A3B, okay, that's 0, right? So that's just 4. Is everybody cool with that? All right. And then it's A3B1, that's 0, minus A1B3, so negative 2. Is that cool? Okay. And then A1B2, so negative 1 minus A2B1, negative 1 minus 6, negative 7. Now take a minute. Now find. Is everybody cool with that? You guys get that? I mean, it's nothing intense. The math there is like, come on, really? Yes.
But we're going to want to memorize that.
This one, I'm probably. I still got to show you the shortcut, but I probably would still give it to you. I don't want that to be the problem. There's a way to work it out with a matrix, so I want to show you that just in case you're curious. And it's not even using true matrix stuff. I'll show you. All right, let me just show you right now. I keep saying I'm going to show you. Let me just show you. So is everybody, you all have seen matrices before. Is that a true statement?
That is true.
I don't mean to say it like that because then you're like, I don't want to say no. Has anybody never used matrices before at all?
They're going to make you
If you haven't, I'm sorry. Go back and slap your pre-count teacher. Just slap. It was me? If you had me for pre-count, we definitely did. So watch this. This is a way to remember. So here I would do 1, 2, 0, 3, negative 1, 2. Now watch. Here's the idea. It is finding the determinant, but you don't even need to know that because here's the shortcut. Just write it again over here. Now watch this. You ready? So here's the idea. This way is positive. This way is negative. What do I mean? So it'll be 4i. You guys see that? I times 2 times 2. Plus 0j. Minus 1k. Now go this way. Plus 6k. I'm sorry, minus. My bad. These are all minus now. Is that cool? Minus 6k. 0. Minus 2j. So I get 4i negative 2j minus 7k. Is that what we got? Yes. Is that cool?
Yes.
That's crazy. It's just a coincidence that finding the determinant of a matrix actually becomes this for a 3x3, which actually relates to the work that's needed to find the cross product. That's all coincidence to a certain degree. So don't read too much into this, but it's just another way to kind of do it quickly. All right, so do you guys see how that kind of works? Because this is insane, trying to remember, was it A2B3 or A3B? No. Now, real quick, find the angle between, some of you find the angle between these two, and some of you find the angle between these two. Pick one. Everybody's going to do the one with 0, but oh well. Somebody pick the one that doesn't have 0. Find the angle between those vectors. Pick one of these. Do this one and this one, or this one and this one. You guys kind of with me? Find the angle between those. Some of you guys don't know how it should come out, probably, maybe. But I want you to actually see it happen. Hopefully it works. It'll suck so bad. Well, I did this 2 ways. It's got to be right. Shit. Yeah.
You can also break it up into minors.
Total, exactly. I mean, if that's
Sometimes
easier,
you get this huge list of algebra.
I got you. I'm with you. So yeah, you can do the I times this determinant.
You can show them that too.
I don't know if I want to get into a whole determinant lecture, to be honest. Especially not today. All right, how do I find, in general, define the angle as the inverse cosine of?
The inverse cosine. Generally,
Yes.
A vector A times vector B divided
Dot product is 2 A dot B.
by the magnitude of A times the magnitude of
All right, cool. So in this case, it'll be inverse cosine. So if I do these two, what's the dot product going to be?
B. 4 plus 0,
4
0.
minus 4
Yeah.
plus 0. 0 over who cares? What's the inverse cosine of 0?
Inverse cosine.
90, right? Cosine likes x. Where is it in 0? It's going to be at the y-axis, 90 degrees. And very quickly the other one. So, I mean, this should have been quick either way. The other dot product is 12 minus 2. I'm sorry, 12, try again, Jeff. Plus 2, 14, minus 14, 0. So what's true? The vector we just calculated using the cross product, how is it related to the two vectors that created it?
It's orthogonal.
Or, I love it. Perpendicular or orthogonal is the more general way to say perpendicular. I like it. Or just another way to say it. There's actually even more ways to say it because we just love the idea. We gave it many names. It's like snow for Eskimos.
How was the other one?
What's that? Same way, because the dot product comes out to be 0 again. Over who cares? Yeah. You guys understand? So the cross product is a vector of length. I deleted it. Of length this, whose direction is defined by being orthogonal to the two vectors that created it. So any two vectors that I give you, as long as they're not collinear, two vectors define a what? Geometric shape. Two vectors. 2 points define a line. 2 lines that aren't collinear define a plane. So if I cross those two, the result ends up being something perpendicular to every vector in that plane. So it's kind of freaky. If I just drew two vectors and I said, all right, these are orthogonal to each other. Now draw one more vector that's orthogonal to both. You guys would have been like, what the shit?
Yeah.
But where's the answer?
Positive.
This one. So saying draw it is kind of mean. You just draw a line on a piece of paper and then hold it. There it is, Jeff. I did it. Yeah. Yes.
Don't they have that thing where it's you put
Yes.
a circle and a dot, and then the other way is
Yes.
X?
So you got like an arrow, right? Very rough arrow. So from behind it looks like this. So if it's going in, so I don't. We talked about right hand rule, haven't we? So if I was doing A cross B, you put your this in the direction of A, but then you got to curl it in the direction of B. If I'm doing A cross B, it would be into the board. A cross B, the result is into the board. We talked about that, about how to set up the coordinate system. Because I need the z-axis to be perpendicular to both x and y. The right-hand rule says which direction it has to point. So if I did B cross A, it'd be coming out of the board. Perfect 180 degrees from each other, and that's why the signs would change in the answer. So this was A cross B. What would B cross A be?
-7.
Negative 4, 2, 7. Point in the complete opposite direction. You guys are right. You all look very shell-shocked. I don't blame you. But again, I wanted to get all these ideas out there today so that Thursday we can just kind of focus on some group work on everything we talked about today.
And then the quiz.
Quiz Wednesday, next Wednesday, basically on everything we do on that we review on this Wednesday. Yeah, I'd say you could get into section